Woohoo, it's Tuesday. I'm excited, aren't you? I knew you were. All right, so today we're going to continue solving systems, but instead of by graphing, today we're going to use a little algebra method called substitution. Now, this substitution method works best when one or more of the equations are solved for a variable. So if you don't know what that means, I've highlighted it there for you. That means that one of the equations already has an x equals or a y equals, where the x or y has already been isolated. So when you find that, circle it. That's going to be kind of a huge part. So first step, we're going to substitute the solved equation, the one we just circled, into the other equation. So again, if you notice, that top equation says y is the same as 2x plus 3. So everywhere I see a y, meaning or in the other equation, I can replace the y with 2x plus 3. It's like trading a dollar for 4 quarters. They're equal, so you can do it even though it's uglier. All right, so now that we've substituted, our next step is to go ahead and solve. The whole idea of what we just did here is we went from a problem that has 2 letters. When there's 2 letters, there's infinite answers, to a problem that has 1 letter, just x. When there's only 1 letter, x, we can narrow it down to the exact answer. So I went ahead and substituted and then solved. So first thing I would have had to have done would have been distributive property here, and you can see that I've done that. Then I went ahead and combined my like terms, 4x and 10x, or 14x. Then you don't see it, but I minus 15 on both sides. And then the last step, I would have divided both sides by 14. That's how I was getting that. But again, that's algebra 1. And then we have the first half of the answer, x equals negative 2. Then we're going to substitute that answer back into the solved equation, the one I circled back at the beginning, because that one that's already been solved for y is set up to quickly and easily find y without having to do very much. So I'm going to use that one, y equals 2x plus 3. And I'm going to replace the x with what I just found out. I just found out a moment ago x was negative 2. So 2x plus 3 becomes 2 times negative 2 plus 3. 2 times negative 2 is negative 4. Negative 4 plus 3 makes negative 1, so I have now my second part of my answer, and then my final solution should be written properly in an ordered pair form with the negative 2, the x answer first, and the negative 1 or y answer listed second. All right, so let's try some different possibilities of what you will see today. All right, starting with what I call an easy one. All right, I've already got an equation that's been solved for y, and it doesn't even look like a very hard equation, just y equals 5x. So what that means is every time I see a y in the other problem, I need to replace that y with a 5x. So I got negative 2x plus 3, no more y. Y is replaced with 5x now. Now solve. Multiply things out, get rid of those parentheses. 3 times 5 is 15. Then I would combine these like terms. They both have x in them. Negative 2 plus 15 makes 13. And then I need to divide both sides by 13. You should, for the most part, get nice whole answers today, but it's possible that you get a fraction or a decimal. Definitely possible. Now, I got 2 different choices. I can go take that x equals 2, and I can plug it back into this equation right there, or I could go back and plug it into this crop equation right there. Well, one of them is set up to be much, much, much faster. The one that we've already circled at the beginning, the y equals 5x equation. We circled it because we needed it at the start and we needed it again at the end. Replace the x with a 2, and this one was pretty simple. My y is 10. So there's my final answer, 2, 10. Now, if you're wondering, could I have I used the other equation? Would it still have worked? The answer is yes. You could have absolutely used the other equation for this last step. And once again, just like before, replaced the x with a 2. That's what would have happened next. So negative 2 times 2 plus 3y equals 26. That would have been negative 4 plus 3y. And then you'd have had to have added 4 on both sides. 3y equals 30. And then divide both sides by 3. So you would have got the correct answer still, but that was about 10 times more steps and more work than it was by using the other one, where all we did was plug in a 2 right there and did 5 times 2 and we had 10 and we were out. We were done. That was way faster. So that's why we want to use that one we circled. So let's go through a couple more. All right, so the first thing, let's find our solved one. There it is. And that means that this 4x minus 3 is going to go into the other equation where the y is. So 6x minus 3y, and again, y is now being changed. It's not y anymore, it's now 4x minus 3. Now let's solve this. It's going to require a little bit of algebra skills. First off, distributive property, negative 3 times 4x, and then negative 3 times 3. Then I've got these like terms over here that can be combined for negative 6x plus 9 equals negative 3. Now get rid of the add subtract number first. And then lastly, get rid of your multiply divide number. And I got x equals 2. So my final answer has an x coordinate of 2. Now to find the y coordinate, I get a choice. I can go put a 2 in for this x right here, or I can put it in for this x right here. It doesn't matter, but one of them is set up for us to quickly and easily solve. The one that's already solved for y. That means all I got to do is plug the right number in, 2. Everything else should be simple. 4 times 2 is 8, minus 3 makes 5. No real algebra steps, just basically calculator work. All right, let's try a couple more. Well, actually, one more. One more. All right, so last one. What makes this one different is that if you'll notice, both equations are solved for y already. So that's okay. It doesn't really matter. We'll just pick one. It makes no difference. And that means every time you see the y in the other problem, replace it with negative 2x plus 4. Well, it turns out this time the y was already all alone on the left, so that left-hand side gets replaced with 2x plus 4. Essentially, we just set these two things equal to each other. The negative 2x plus 4 equal to 3x minus 11, because they both equal y, so they should be equal to each other. So this one, a little bit different, because I'm going to have to get my like terms together by making one of them disappear, because they're on opposite sides of the equal sign. You can't just put them together. So I'll have to make one of them disappear. I like to make the one on the right disappear. It just makes me feel better. I like my x's on the left. Now this should look similar to the last few problems. Now you'll minus 4 on both sides. And then divide both sides by negative 5. So not too much craziness here. Pretty basic and similar to the last ones. And now that we have an answer, go back to the one we circled. Actually, it doesn't really matter. Go back to either of them. They're both kind of easy. And replace the x this time with a 3, because that's what we just found out. We just found out x equals 3. So change it to a 3. See what its partner is. Negative 2 times 3 would make negative 6. And negative 6 plus 4 would make negative 2. All right, hopefully these make enough sense for you today. Let me know if you need any help. Good luck.